Hi everyone. So yesterday we have seen few of the questions of the chapter matter surrounding us. Okay, so we are going to continue these questions today also. So question number 3, give reasons. So they gave some questions. We have to give reasons for those questions. So a gas fills completely the vessel in which it is kept. So they are saying that a gas is going to fill, if I take any vessel, a gas is going to fill completely here. Okay? So why? So the molecules of a gas have high kinetic energy due to which they keep moving in all directions and hence fill the vessel completely in which they are kept. So in gases, what happens? The molecules are going to move, right? So move freely, okay? As because they are very far to each other. So they are going to strike each other and they are going to move freely in the whole container. Okay? So that's the reason why the gas is completely filled with the air completely. Okay? So next question. A gas exerts pressure on the walls of the container. So on the walls of the container, if you take any container, so here on the walls of the container, there will be having a pressure force. Okay. So why? Because a gas exerts pressure on the walls of the container because the molecules of the gas are in constant random motion due to high kinetic energy. So kinetic energy is nothing but it is the minimum energy required to move or to do any work, right? So here the same thing. This question and this question is somewhat same here. So the pressure of the walls is going to walls of the container are going to exert pressure because of the random motion. Random motion is nothing but the random movement of the high particles as they are having high kinetic energy. These molecules constantly vibrate, move and hit the walls of the container, thereby exerting pressure on it. Okay? So next question. A wooden table should be called a solid. So if I take any wooden table, what we are going to call that as? We are going to call it as solid. Yes? Okay? So in solid we all know that particles are tightly packed. There is no gap between the particles. Yes or no? So why it is called as solid they are asking. So the molecules or particles of the wooden particle are tightly packed with each other. There is no intermolecular space. It cannot be compressed. It cannot flow. All these characters are of which thing? Solid, right? So wooden table should be called as a solid. Not only wooden table, all the solid items, okay, like pen, okay, book, whatever the solid items you are going to see around you, all those are called as solid because of the tightly packed particles and there is no intermolecular space. So intermolecular space is nothing but between two particles we are having some space. So that space we are going to call it as what? Intermolecular space, right? So in solids there is no space. Which space? Intermolecular space. So the particles are tightly packed here. So that's why there is no intermolecular space between the particles. In which thing? In solids. Okay. We can easily move our hand in our air, but to do the same through a solid block of wood, we need a karate expert. So in air we can move the air easily, right? But by holding a solid block of wood, can we do that? No. Why we require karate expert? Why? Because we can easily move our hand in air, but to do the same through a solid block of wood, we need a karate expert because the molecules of air have less force of attraction between them and very small external force can separate them and pass through it. But in case of solids, the molecules have maximum force of attraction. The particles are tightly bound due to this force, hence large amount of external force is required to pass through the solid. So you have seen that some wooden blocks will be there, kept one below the other. Okay, can we break this with our hand? We cannot break this, but the karate expert can break this, right? If in air we can easily move our hand. Okay, that means we are breaking the air here. Okay, finger we are breaking the air here. Can we break the solid here? No, because we are not having that much energy here. And but in air we can easily move our hand. So that's the same thing here because in air the particles are loosely arranged. Okay, and in solids the particles are tightly arranged. So to break these particles, here the karate expert is going to have more energy, so he can break it easily. Okay, we are not having that much energy. So the intermolecular space is also present between the particles in which thing in air, but it is absent in solids. So that's the difference between a karate expert and a normal person. So they are saying because the molecules of air is having less force of attraction between them and very small external force can separate them and pass through it. So if I take my hand and I divide the air, I can divide it by separating the air molecules. But with the help of my hand, I cannot break the bricks or a block of wood. Okay. So next question. Liquids generally have lower density as compared to solids, but you must have observed that ice floats on water. Find out why. So liquids are having lower density. That means what? If I throw water on the floor, what happens? The water is going to flow, right? So this movement we are going to call it as what? As I said earlier, density is nothing but thickness. Okay? So the water is going to flow easily. But most of you have observed that ice floats on water. Ice is also made up of water only, right? Okay, ice is going to, as it is a solid, it should sink in water, right? But it is going to float on the water. Why? Because ice is a solid, but its density is lower than water due to its structure. The molecules in ice makes a cage-like structure with a lot of vacant spaces. This makes ice float on water. Because if anyone asks why ice is a solid, if anyone asks whether ice is a solid or liquid, what you are going to say? You are going to say ice cube is a solid. But it is not going to. That means if it is a solid, it is having more weight, right? It should have more weight. As that is nothing but it should be having rigidity more, right? And the density is also more. It should sink in water. Completely it should sink in water. But it is not going to sink in water because of the molecules that are present in the ice are going to arrange in a cage-like structure. Okay? If you see properly, the ice molecules are going to arrange in a cage-like structure. So that's the reason why the vacant spaces are present between the ice and the ice is going to flow in the content or it is going to flow in the water. Understood? So next question. Convert the following temperature to Celsius scale. So K here represents what? Kelvin. Okay, C represents what? Celsius. Okay, you all know this, right? So let us convert this 300K and 573K into Celsius. Okay. So here to convert the Kelvin into Celsius, what we have to do? We have to just minus 273. Okay, that is nothing but 27 degree Celsius. And for 573 minus 273, 300 degrees Celsius. So, if anyone asks you to convert the Kelvin to Celsius, just we have to minus 273 from that number and we are going to get the value in the Celsius. Okay. Next question. What is the physical state of the water at 250 degrees Celsius and 100 degrees Celsius? So physical state is nothing but how it is going to appear. Whether it is going to appear like liquid or it is going to appear like solid or it is a gas. Okay. So physical state is nothing but the outer appearance of the water at these temperatures. Okay. So at 250 degrees Celsius, gas. At 100 degrees Celsius, liquid as well as gas. So what is the boiling point of water here? So boiling point of water is 100 degrees Celsius. At 100 degrees Celsius, you are going to see some of the water is going to become gas and some of it will be liquid. When it will be ice at 0 degree Celsius. So above 100 degrees Celsius, it is going to become gas. So next question. For any substance, why does the temperature remain constant during the change of a state? So for any substance, if you take any substance, the temperature will become constant at certain stage. Okay, while it is going to change to the other state, the temperature will be constant. Is nothing but remain same here. Constant is nothing but what? Remain same. During the change of the state of any matter, heat is supplied to the substance. So to change from one thing to another, example, to change from solid to liquid or liquid to gas or gas to solid, gas to liquid. Okay. So when there is a change in physical state, the temperature is going to have some constant temperature. So the molecules of this matter use heat to overcome the force of attraction between the particles. At this period of time, temperature remains constant. This extra heat is acquired by the molecules in the form of hidden heat called as what? Latent heat. To change from one state of the matter to the other state. So here, latent heat is nothing but what? It is the heat applied to any substance through which it is going to change from one state of matter to the other state. So we can say the minimum heat, okay, that required to change the physical state of the substance. Okay, when heat is applied, what happens? The molecules are going to separate. Okay, so that's the reason why they are going to change from one state of matter to the another state, and temperature is going to remain constant. So if I boil the water for 100 degrees Celsius, it is not going to boil more than that. It is going to become, the liquid is going to convert it into gas. If you observe it properly, when your mother keeps water on the stove and leave it for few minutes, what happens? The water is you are not going to find the water, or the level of the water is going to be decreased. Yes. Why? Because it has been converted into gas. Okay. Because why it has been converted into gas? Because heat is applied. Okay. Next question. Suggest a method to liquefy atmospheric gases. So here in this thing, what we are going to do, here the gas is converted into liquid. Okay? So if you observe it properly, when your mother is going to cook any food, what happens? If she kept any plate on it, below the plate, you are going to see some water droplets. Yes? So, that water droplets are nothing but the vapors which are from the bowl. Okay? These vapors have been converted into liquid. So, this process is nothing but what? Liquefying process. So, in the same way, the atmospheric gases we are going to convert them into liquid. How? Let us see. The atmospheric gases are taken in a cylinder with piston filled on it. By cooling and applying pressure on them, the gases can be liquefied. So if you see the image here, piston is, we are going to call it as piston, and this is the gas, and this is the cork. Cork is nothing but there is a small cap like thing, okay? So here piston is nothing but it is going to move. So if we hold it here and if we pull up, it is going to come up, and if we pull down, it is going to move down here like this. So when we pull it down, what happens? The molecules, the particles which are present in this container, what happens? They are going to press it tightly. Okay? See, the level of this piston you can see. Okay? That means what? This piston has been moved down. Okay? Compressed here. And the gas is cooled here, so that what happens here? The loosely arranged molecules have got it into somewhat liquid like this. Okay? And this process we are going to call it as what? Liquefaction or liquefying atmospheric gases. Next, so this is about liquefying atmospheric gas. So we are going to continue in the next video. Thank you for watching the video. For more videos, please subscribe Go Easy Tutorials.